Okay, this is a video solution for assignment 37, question N8. So in N8, you're given a model for the height of a buoy in a water at time t hours past midday. And the model you're given is that the height of the buoy is 14 plus 4 sine t plus cos t. And the first thing we're asked to do is we're asked to basically rewrite this model in the form 14 plus r cos t minus alpha. Okay, the reason we're going to do this is going to be much easier to deal with. If we're able to write this model in this form, it's much easier to see what's going on than in its current form now. Now, if you're not sure how to do this at all, you probably want to have a look back at the video solutions for N7, which explains how to do it, okay? But I am going to go through the process here again anyway, but N7 will explain this process as well. I'm just going to, for this first part, just ignore that 14, because I can see that it stays there, but just look at basically rewriting 4 sine t plus cos t in the form r cos t minus alpha. So, doing that, I'm going to write r cos t minus alpha is equal to 4 cos t plus 4 sine t. You might have noticed there that yes, I've multiplied it out, but I've also written the cos t first. The reason is when I use the compound angle formulae to rewrite cos t minus alpha, it's going to be basically my cos parts that appear first effectively, so it's just easy to compare these things. Alright, so rewriting this, like I said, I kind of mentioned how to do this and what's going on a bit more in the video solutions for N7. I'm going to write that as r cos t cos alpha plus r sine t sine alpha. Move that down. Okay, and then comparing things, well basically this is my cos t term, this is my cos t term. So I know from that r cos alpha is equal to 4, and vice versa over on this term, sine t, I know that r sine alpha is equal to 4. Going from there, I know that r squared is equal to 4 squared plus 4 squared. Again, if you're not sure where this comes from, speak to your lecturer. So r is the square root of that, which is 4 root 2. Dividing the two different equations I've got, I get r sine alpha over r cos alpha is equal to 4 over 4. Why does that help me? Well, that means that tan alpha is equal to 1. So going from there, alpha is going to be equal to, I was about to write 45 degrees, but I believe we're in radians for this question. Let me just double check. Yes, we are in radians. So alpha is equal to pi over 4. So how can we rewrite that model in the form we were asked to? I can basically write the model for the height of the buoy is equal to 14. Don't forget that 14 was there. Plus 4 root 2 cos t minus pi over 4. And this, as I said before, is much easier to deal with. It's just my email going off. This is much easier to deal with when it's in this form than when it was in its original form. Next bit, we're asked about the minimum. I'm just going to move this. We're asked about the minimum and the maximum height of the buoy. Well, let's do the maximum first. So the maximum height of the buoy. Well, let's just consider cos of t minus pi over 4. What happens to that? Well, basically, if you look at the range of that bobs along between 1 and negative 1. Okay? So when is the maximum going to occur? Well, that maximum for the height of the buoy is going to occur when cos of t minus pi over 4 is equal to 1. Okay, and when it is equal to 1, what will the maximum be? Well, the maximum will just simply end up as 14 plus 4 root 2. So that is the maximum. Whoops, that was meant to be me scrolling rather than doing a line there. No. Try again. There we go. So that is the maximum. And when does it occur? It occurs when cos of t minus pi over 4 is equal to 1. So we've got to solve this. So solving that, I get t minus pi over 4 is equal to 0. My next solution along would be 2 pi. Now I'm asked, when does it, when's the first positive value of t for which it occurs? Well, actually, when I add the pi before, it's going to be, this 0 is going to be the one that I'm going to use. So it's not going to be that one there. So I'm just going to use the t minus pi over 4 is equal to 0. So t is equal to pi over 4. Now I've just got to, don't leave it there, just think about the context of the question. Basically t represents the number of hours after midday, and I'm asked the time after midday which it occurs. So I need to get this basically into a time after midday. So t is equal to pi over 4. From that, if I just get that as a decimal to a few decimal places, t is equal to 0.7854 hours after midday. Now 0.7854 hours after midday is 47 minutes, I believe, to the nearest minute. And that's 47 minutes after midday. So the time that maximum height occurs after midday, the first time, is at 12:47. That is when the maximum height occurs for the first time after midday. For the minimum, it's going to be a very similar process. So my model representing the height of the boy is 14 plus 4 root 2 cos t minus pi over 4. Okay. When do we get? When does the minimum height of that boy happen? Well, again, think about this bit here. Think about cos of t minus pi over 4. All right. Think about the range of that. Again, something like this. When's the minimum going to occur? It's going to basically occur when cos of t minus pi over 4 is equal to -1. Now, when it is equal to -1, what is that minimum going to be? It's going to be 14 minus 4 root 2. So that is the minimum height of the boy, in meters, I think. Should be putting that really. I don't actually check the units, but I'm assuming it's in meters. Okay, so that's the minimum height of the boy. And then, when does it occur? As we said, it's when cos of t minus pi over 4 is equal to -1. So we need to solve that. Moving down a bit. So solving that, we get t minus pi over 4 is equal to pi. I can see straight away. Another solution here. I could start looking at the other solutions, but actually I can see straight away when I add pi over 4, this is going to be the one that I'm after. This is going to be the one that I want. If you're confused at all about multiple solutions and things like that, do speak to your lecturer for a bit of help and a bit of guidance on that. So I can see here t is going to be equal to pi plus pi over 4, which is equal to 5 pi over 4. Again, that is the number of hours it occurs after midday. Whoops. Let's try and scroll that again. Ignore that line there. So that's the hours it occurs after midday. So just getting that as a decimal. Is first time after midday. Okay, that's the video solutions for, I think that was N8 on assignment 37.